today, all focusing on particle charge and how particles interact.
Yeah,
And honestly, diving into this feels like we're getting a real look at how things fundamentally, work.
it really is. I mean, charge isn't just like a simple plus or minus sign they teach in high school. It's this deep intrinsic property,
Uh huh.
and it dictates pretty much all electromagnetic interactions. It's crucial for understanding how matter itself is structured, the forces involved, everything.
Right, absolutely. So think of this for you listening as maybe a shortcut into one of those really core building blocks of physics.
Mhm.
So, based on the material you shared, our plan is to unpack what charge actually is.
Yeah, what it is, how it behaves, what carries it.
What carries it exactly, and maybe most importantly, why understanding it is so fundamental.
Right. Our mission really is just to pull out the key ideas from these sources,
Yeah.
the most significant insights to give you a clear picture.
Okay, let's jump right in then. The sources seem to start with the absolute basics: electric charge.
hmm It's an intrinsic property, meaning particles just have it, kind of like they have mass. It's not something added on.
And it's the thing that makes them feel the electromagnetic force. It can be positive, negative, or
Yeah,
nothing, neutral.
exactly. And the immediate consequence, the rule that governs so much is super simple. Like charges push each other away, opposites pull together.
Like repel, opposites attract. Simple. Got it. The sources lay that out as the starting point for pretty much everything else electric or magnetic.
Yeah.
Now, here's where, for me anyway, it starts getting really counterintuitive, and the sources spend some time here: charge quantization.
Ah, yes, quantization. What the sources really emphasize is that charge isn't continuous. You can't just have any amount of charge.
Okay.
It comes in these discrete little packets. The smallest chunk of free charge you can find, the fundamental unit, is called the elementary charge. We use the letter E for it.
So any isolated particle, if you measure its charge, it's going to be a whole number multiple of this E, like plus 1m or negative 2e or 0e.
Precisely. It's like you can't have half an electron's worth of charge floating around freely. The value of E itself is tiny, about 1.602 times 10 to the minus 19 coulombs.
Wow, okay. But wait, the sources do mention something about fractional charges, right? With quarks?
They do, and that's a crucial point. Quarks do have these fractional charges, like plus or minus one third E or plus or minus two thirds E.
And this is the key thing the sources stress.
Yeah.
You never actually see a quark on its own carrying that fractional charge.
Exactly, because of something called color confinement, which, yeah, we definitely need to circle back to because it explains why we only see these integer multiples in the particles we actually observe, like protons.
Okay, so quantization is one big rule.